Last week, what we looked at was this issue of calculating the time value of money. Okay, that was really, and we looked at the IPRT and we looked at manipulating it in a number of ways. Now, sometimes, and in fact, most times in business, one of the things that we want to do is to be able to predict how much is something going to be worth in dollar value today. And what I mean by that is, let's say, for example, someone were to give you some money, okay, or give you a choice of some money. So here's the choice that I'm going to give you. I can give you this dollar right now, or I can give you $1.10 in 1 year from now, okay? So the thing is, if you look at that and you ask yourself, why is he giving me more next year? Is that something that is a better deal? Would I wait a year and get $1.10? Well, if we think about that, we have to consider the time value of money, okay? Because we know that money today is worth more than it's going to be in the future. So we say, okay, that's very good. What is, or what value will that dollar be in a year? Or if I got the dollar now, I could invest it for a year. So we could look at it in a number of ways. Let's just look at it this way right here. So what I've got is an example here that says, suppose you can receive, you can choose to receive $1 today or $1.10 in 1 year from now. If you choose the dollar today, so let's assume that you said, okay, Paul, I'll take the dollar from you today, and you were to invest it. You put it in a bank account or something, and let's assume that that investment could earn a 10% rate of return, okay, a 10% rate of return. What would that mean? Well, that dollar would sit, and it would sit there for a year, and it would earn interest on it, and that interest would amount to, in 1 year from now, 10% of that $1. So 10% of $1 is 10 cents. So effectively, in 1 year from now, if you looked in the bank account would say there's $1.10 in it. So if you look at this little graphic that I have here, dollar now, it earns 10%, it grows a little bit, hence this slope, a little bit of slope. So right at the end of that year, you'll have $1.10. We call that $1.10 that you get in the future the future value, okay? That is the future value of that dollar. So realistically, you're going to say to me, I'm indifferent. You can give me the dollar now, or you can give me $1.10 in a year's time, because really, I know that if you give me the dollar now, I would have $1.10 in a year's time because I'd put it in the bank and it would earn money. Now, there might be other reasons you'd want it now, but in the meantime, effectively, you're going to say, it doesn't matter. You can give me $1 now or $1.10 in the future, because if you gave me $1 now, I'd put it in the bank and I'd have $1.10. So that's what we mean by future value. It's the value of an amount at some point in time in the future. So what is the equivalent value of it? We also have this concept of present value. And what present value does, if you were to think about it now, let's zoom you ahead to 1 year in the future. And you said to yourself, okay, I have $1.10 today, which is 1 year in the future. How much would I have had a year ago? So looking backwards. So if you look backwards, the present value of that $1.10 1 year before would have been $1. So it works on the backwards. So sometimes we want to look forward. We want to get a future value. Other times we want to look backwards and see what was the value worth, what was it worth at some point in time earlier on. So this is what we mean by future value and present value. The future value looks at the value at some point in time in the future. The present value looks at the future, looks at the value and says, what was it at some point in time earlier? These are incredibly important calculations because a lot of business decisions are based on making decisions on money over time. And so we say, okay, like how much is Churchill Falls really going to cost us if it takes us 40 years to pay it off? That sort of thing, right? So you can imagine that when you're doing these calculations in business, these calculations or this calculation or perception of future value and present value is important in the decision making. So it's important to know how to do it. Sometimes to the word future value, we use the word maturity value. They both mean exactly the same thing. So there's no difference between future value and a maturity value. It's synonymous. So effectively, we have to ask, well, how can we quickly and easily calculate the future value of something? Well, so when a loan or investment reaches the end of its term, it says to mature. And the last day of the term is called the maturity date. The maturity value or future value is the total of its original principal plus the interest due on that maturity date, $1.10 in my example. Using the symbol S to represent the maturity value, here is the formula. So the formula is a derivation of the I equals PRT formula. So it's the future value is the principal bracket 1 plus the rate times the time bracket. So I have a little example here. Selena invests $1,500 by lending it to Aiden for 8 months at an interest of 4.25%. What is the maturity value of the loan? So what we're asking is, okay, here's $1,500 now. What's it going to be worth in 8 months' time? So we got the principal, $1,500. We got the rate, 4.25% annually. We have the time, which is 8 months, which is 8/12 of a year. We throw that information into the formula, and you can see, for example, S is 1 plus RT. The S then equals $1,500 times 1 plus the rate times the time, which is 0.0425, which is 4.25% in decimal. It's 8/12. So this comes to $1,542.50. In other words, if you took $1,500 and you sat it in the bank earning 4.25% for 8 months, at the end of the 8 months, that's how much it would be worth. Okay, so that's what we call the future value and the future value calculation. The future value casts ahead. So it for example, in my little graphic, this is the future value right here. We know an amount now, and we're trying to find out what it's going to be at some point in time in the future. But we can also look backwards, and backwards is exactly the reverse. So if we took that formula, this formula, and we solved it for P, effectively, we put the P on this side, this is what the formula would look like. So all you really need to know is this formula here, and then you can revise it to this one right here. So we calculate the principal equals the future value, or 1 plus RT. So it's just a revised formula to calculate the version of P. So what amount of money would have to be invested at 3.75% to grow to $10,000 after 291 days? I always find that it's useful to draw some sort of a number line on this. That makes it easy to do because we can get a better sense of past, future, future, past, that sort of thing if we draw a number line. So effectively, we want to know what amount of money would have to be invested at 3.75% to grow to $10,000. So $10,000 is at the end. So that's the future value. 291 days is the length of the number line. So what we're looking for is the value at the left, which is the present. So the good thing with a number line is present sits on the left and the future sits on the right. Okay, time moves forward. We just throw that into the number line. So we know that the rate is 3.75, which is 3.75 or 0.0375 is the decimal. We've got the time, 291 days, 365 days in a year. So 291 divided by 365. We throw those numbers into the formula. So that's S, 10,000 divided by 1 plus RT, which is the rate, 0.0375 times 291 over 365. That equals 10,000 divided by 1.029897. Notice we've got about 5 or 6 digits here past the decimal, and you need that because you'll get a rounding error. So you need certainly that numbers. And it will come to $9,709.71. So effectively then, this is the present value. You'll notice that the present value is always a smaller number than the future value because as time rolls along, the money, you need more money to buy the same value. So the higher number will always fall in the future. So effectively what we're saying is if we took 9,709.71 now and we sat it in the bank at 3.75% for 291 days, at the end of the 291 days, it would be worth $10,000. So that's the simple formula of that. So realistically, what we need to be aware of is the future value formula, S equals P times 1 plus RT. And we need to know the present value formula, which is just a derivation of that formula, which is P equals S over 1 plus RT. So the real trick then, if we, the formulas are pretty good, is to figure out what are we dealing with? Are we looking for the present value or are we looking for the future value?